Okay, so now to graphs of quadratic functions in 10.4. Graphs of quadratic functions. The graphs of quadratic functions are also called parabolas. So let's recall. If you recall, graphing f of x equals x squared. This is one of the basic graphs that we talked about. So if you plug these values in, you get 4, 1, 0, 1, 4, and you graph it. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So you get the U-shaped graph. Okay, and then if you go to example 2, f of x equals x minus 2 squared. Remember that moves the shifts the graph 2 units to the right. So you get a parabola that looks like this. And that's 2, 0 instead of 0, 0. And if you want to do f of x equals x plus 2 squared, that shifts the graph 2 units to the left. And if you want to do f of x equals x squared plus 2, that shifts the parabola 2 units up. So it would be 0, 2. And if you want to do f of x equals x minus 2 squared plus 3, that's gonna go to the right 2 and up 3, to the right 2 and up 3. So this vertex is at 2, 3. And if you want to do f of x equals negative x minus 2 squared plus 3, that's gonna shift 2 units to the right, flip it, and then up 3. So it'll be upside down. Okay, the vertex is at 2, 3. So having said all that, if you look at 34, it shows you all these steps, and I also have it on a handout, under handouts. So this is not in the notes, it's in the under handouts on D2L. So if you have f of x equals a times x minus h squared plus k, this is the quad function. The graphs are called parabolas. This is what we call standard or vertex form. If a is positive, the parabola opens up. So this function has a minimum value. You can see all these have a positive a. So it's got a minimum at 0, 0, at 2, 0 minimum. All these are minimums. And then a minimum, but then if a is negative, it's upside down and you have a maximum. Okay. The vertex is at hk. H is the opposite of what's inside the parentheses, and k is the value on the outside. Opposite, same value. So look, let's see that. So this x squared is actually x minus 0 squared plus 0. So the vertex is at 0, 0. This is x minus 2 squared plus 0. The vertex is at 2, 0, which is right here. Number 3, x plus 2, 0. The vertex is at negative 2, 0. It's opposite that. This is x minus 0 squared plus 2, so it's at 0, 2. This is at 2, 3. At 2, 3, and this is at 2, 3. That's how we find the vertex. And then the axis of symmetry is x equals h. It's the vertical line that splits the parabola in half. It's a vertical line that splits the parabola in half. It's at x equal the x value of the vertex, always. So over here it's going to be x equals 0, which is the y-axis. This is at x equal 2. That's the line that splits the parabola in half. This is at x equal -2. This is at x equals 0. X equal 2 is the line of symmetry, and x equal 2 is the line of symmetry. We always have to write this down. To find the x-intercept, it's the value where the function intersects the x-axis. You set y equals 0 and then you solve. To find the y-intercept, it's the value where the graph crosses the y-axis. Then you put it in, there's always 1. You put x equals 0 and solve. And now this is number 7 is going to come later. We'll talk about it. So let's see an example about all this. So how do we graph the parabola? So graphing it is going to require showing all what we talked about, and on the test I will list the things that you need to show, okay? So you don't have to guess. Graph the parabola or the quadratic function f of x equals x plus 1 squared minus 2. So on the test I will put number 1 and I say find a, and then tell me whether it's up or down. So a is 1 in this case, and it's going to be up because it's positive. If it was negative, it would be down. Okay. Then I say what's the vertex? It could be a minimum or a maximum, the opposite of what's inside the parentheses, and then the same thing on the outside. The axis of symmetry, it's always x equal the x value of the vertex. It's not if you put -1, that would be wrong. -1 is a number. X equal -1 is a vertical line. So don't just put -1 if you want to get full credit this one. And then you want to find the y-intercept. We'll do that first because it's easier. So we put in a 0 for x and then solve. So y equal 0 plus 1 squared minus 2. That's 1 squared is 1, 1 minus 2 is -1. So the graph will hit the y-axis at -1. The x-intercept, we get this by putting in a 0 for y. So if we put in a 0 for y, I'm flipping it, x plus 1 squared minus. So we get a quadratic equation. Remember, there are 4 methods for solving quadratic equation. The easiest one for this one is square rooting, because if we move the 2 over, then it's done easy by square rooting. We want to find this, the easiest method. X plus 1 is plus or minus root 2. So minus the 1, x equals -1 plus or minus root 2. So the x-intercepts are, there's 2 of them, -1 plus root 2 and -1 minus root 2. If you put this in your calculator, that's 0.4, and that's -2.4 roughly. So it's going to hit the x-axis at 0.40 and -2.40. So we have everything we need about the graph, so let's put it on the graph. Y, x, we start with the vertex is at -1, -2. It's going to be a minimum because a is positive. The axis of symmetry, it's always dotted line, x equals -1. The y-intercept is at -1, and the x-intercepts are at 0.4, 0, and -2.40. And we get the graph, and this is the vertex, which is at -1, -2, and it is the lowest point on the graph, so it's a minimum. Alright, here's another one. Graph the function y equals -2 times x plus 1 squared plus 2. So first, a is -2, so it's going to be upside down. We're going to have a maximum. The vertex Again, we start inside the parentheses. My x value is the opposite of this. The y value is exactly that. The axis of symmetry it's x equal the x value of the vertex. Then the y-intercept, we put in a 0 for x and then solve for y. So to do this, we do what's inside the parentheses, then exponent. So 1 squared is 1 times -2 is -2 plus 2 is 0. So the graph is going to hit the y-axis at the origin. The x-intercept, we get this by putting in a 0 for y. So -2 x plus square plus 2. Remember we said this is going to be done using the square root method. That's the easiest for this case. Divide by -2. X plus 1 squared equals 1. Square root it plus minus. X plus 1 equals plus or minus 1. So x equals -1 plus or minus 1. -1 minus 1. -1 plus 1. So it's -2 and 0. So it's going to be -2, 0 and 0, 0. This is where the graph is going to hit x-axis. And we got all the information, so let's put it on the graph. The vertex is at -1, 2. -1, 2. The axis of symmetry is always the vertical line through the vertex, which is in this case x equal -1. It's going to hit the y-axis at 0, 0, the x-axis at 0, 0, and at -2, 0. And it's a maximum. So the vertex is at -1, 2, and it is a maximum. Okay. So we were given the vertex form, now the quadratic form. What if the equation was this? F of x equals ax squared plus bx plus c. What if it wasn't given where you can get the vertex easily from the equation? Well, we find the handout. So if the quadratic form is given, y equals ax plus bx plus c, the x value of the vertex is given by the formula, and then the y value you can get by plugging that in. So to find the vertex in this case, to find the vertex is hk. H, which is the x value of the vertex, you just -v over 2a. Remember, this is the first part of the quadratic formula. It's not a new formula. You just ignore the discriminant, that's the formula. So you get that, and then to get k, you plug h in, and that's going to give you the k value, okay? And everything else is the same. So for example, if I say, see in the handout, in the notes, I only did the vertex, but if I say graph the function, I want to do the whole thing, okay? Because now I'm doing it at my own time, so I can have the time. So y equals 3x squared plus 4x plus 2. So that's the quadratic form. So we cannot get the vertex straight from the equation. But what we can do, again, a is 3 in this case. It's positive, so it's going to be this. The vertex, to get the vertex, hk. To get h, we do the formula, -v over 2a. It's -4 over 2 times 3, which is -2 over 3. To get k is f of h, which is f of -2/3. So you plug it in. 3 times -2/3 square plus 4 times -2/3 plus 2, which is going to be 3 over 1 times 4 over 9 plus -8 over 3 plus 2, which ends up being 2/3. So the vertex is -2/3, 2/3. Okay. The axis of symmetry is x equal negative 2/3 as usual. Okay, it's x equal the x value of the vertex axis of symmetry. X equals negative 2/3 right there.